Hello everyone, I'm Edo, and today I'm going to talk about the Array.prototype.reduce, which is one of the most useful tools to have in your tool belt, an amazing Swiss switchblade. Array.prototype.reduce or reduce is a higher order function that applies a reducer function on each element of the provided array. So we've already seen in the last videos that an higher order function is a function that takes one or more functions as arguments, or two, a function that returns a function as its result. But what is a reducer function? Well, a reducer function is a function which takes a set of arguments, in this case at least an accumulator and a value, and reduces them to a final value which can be a number, an object, or even an array. So, if we take a look at the signature of reduce, we see according to the JS spec and according to MDN, which I always like to check, that reduce accepts 4 parameters, which are accumulator, the current value that is being iterated, the current index of the value that is being iterated, and the source array, which is the complete array that we are passing into reduce. Then, as a second argument, it also accepts an initial value. We will see how this works as soon as we get our hands dirty. So, in the most cases, we do not need to use these 4 parameters. In the most usual cases, we stand with an accumulator, or we stay with an accumulator and with a current value, which I'm going to call it curve value, and with an initial value, which most of the times is 0, so we do not need to pass it in this particular case. Let's see it in action. Okay, so let's say that I have this numbers array and that I want to calculate the sum of all the elements in the array. So I'm going to create a variable, let's call it sum, and we are going to grab the numbers array, we are going to pass it the reduce higher order function, and the reduce higher order function accepts a reducer function and an initial value. So in this case that we are going to sum all the elements of the array, we want our initial value to be 0. So we want to start our accumulator of the sum of all the values with the value 0. And the reducer function, which you can write it in line here. This 0 is here, sorry. Yes, no, it's correct. Okay, so we are going to write our reducer function with an accumulator and a current value. And here is where all the magic happens, where we state to the reduce higher order function what we want it to do. So in this case, we just want to add, during the iteration of the numbers array, we want to add the current value which is being iterated to the accumulator. So in this case, what we want to return is the accumulator, or the current accumulator value, with the current value which is being iterated. So return, yes. Okay, what will happen here? So what will happen here is that as our initial value is 0, reduce will start with ACC equals 0, and is going to grab the first element of the numbers array, which is 1. So in the first iteration it returns ACC, which is 0, plus the current value, which is 1, and this is equal to 1. In the second iteration it finds the number 4, so it's going to return the ACC, which is currently 1, plus the number 4, which is 5. This 5 is stored in the accumulator variable during the iteration. So in the next iteration it will find the value 2, and it will return what? ACC, which is 5, plus 2, which is equal to 7. In the fourth and last iteration it will find the value 3, so it will return 7, which is the value of the accumulator, plus the number 3, which is 10. So let's see it in action. Let's see if this is true. Let's console log sum and put it in action. I will use Code Runner, which is this add-on, this VS Code add-on here that I've already explained in the array prototype map video. So I simply put it to run, and the sum is 10. Okay, great. So it's a nice opportunity to see what does the initial value. So let's say that I want to sum all the elements of the array, but I want reduce to start with value 100. So in this case, what happened is that reduce started the accumulator with 100, then here it returned 100 plus 1, then here it returned 101 plus 4, and so on. And that's what happened. So let's go to a second example using the same logic. So I'm going to comment this. This is one sum of all values of the array. Yes. And now we are going to tackle the case 2, which is determine which is the biggest number in the array. Okay, this is a slightly different problem, but it's very easy to solve it with reduce also. So I'm going to start to create a variable called biggest, and I'm going to grab the numbers array. I'm going to apply the reduce with a reducer and an initial value. Okay, at this case the initial value can be 0, why not? So let's not use it. And the reducer will be made with an ACC and with a current value. And okay, this is not good. It's like this. Okay, so basically in this case we do not want the accumulator to accumulate the sum of all the elements of the array. So I cannot add the current value to the accumulator. What we want here is to store the biggest of the numbers that we've iterated. So basically ACC will start with 0, and it will check with an if the current value is bigger than the ACC, we want to return the current value. And return current value in this case means store the current value in the accumulator while you are doing your operations. Let's return the accumulator with the value of current value. Okay, so if this does not happen, so we want to return the ACC, which is basically the previous value that was stored in the accumulator. And what will happen here is basically this. ACC starts with 0, and then the reduce goes to the first element of the array. It says it's 1, and is going to get into the if and says current value, which is 1, is bigger than ACC, which is 0. Yes, so let's return the current value. So ACC will keep the value 1, that is the current value. Okay, then reduce goes to the next item in the array, which is 4, and it goes into the if and says current value, which is 4, is bigger than 1. Yes, it is. So let's keep ACC equal to 4. Okay, now reduce goes to the next item of the array, which is 2, and it asks, is current value of 2 bigger than ACC 4? No. So let's return just the ACC, second case. Okay, so ACC keeps the same value as before, which is 4. Last item in the array, which is 3, reduce goes to the if and checks current value, which is 3, is bigger than ACC, that is 4, false, so let's return the ACC. Okay, so ACC is 4, and this means that the biggest value in our array is 4, and let's see if it is. Let's console log biggest, and if you run it, yes, it returned 4. So if I add one more value here, let's say 32, and I run it, it says 32, of course. So great, guys. This is a very handy tool, isn't it? So it's great to solve things like this, but the main functionality of reduce usually is to transform data objects in another data objects. You know, with the evolution of frameworks like React or Vue and the mix of the languages, we usually need this kind of methods to transform our data being rendered into the front end. So let's see a case that is a little bit more complex, but it will show you what Reduce is able to do. I'm going to comment this. Okay, everything is commented here. I don't need this numbers array anymore, so let's put it here. And I'm going to get back to my computer games collection of the 80s. I think that you already know the collection because you've seen the last videos. So if you didn't see, it's a good opportunity to follow me, to click subscribe, and just to check the array prototype map and the array prototype filter videos, because these are the 3 tools that you will need always to tackle your most creative project. Okay guys, so I'm back to my collection of ZX Spectrum 48K video games, and I have this array. Let's imagine this array has 1 million elements, and that suddenly it's more useful to have a different kind of structure for this array. Let's say that we want to do something like, let me show you, like this. Let's imagine we want a games object that kind of sorts my computer games by year, because then if I want to know which computer games were made in the year of 1984, I can just write something like this, you know, and you would have all the games that were made in the 1984 year. So it's a question of transforming data so that it can be used more quickly and in a simple way. So what I'm going here is to transform this object. So I'm going to create a new variable called gamesobj or gamesobject, and I'm going to grab the games array. I'm going to apply the reduce with a reducer and with an init value. So in this case, let me keep my example so that you can see it. Yes, here it is. So basically you can see that we want to pick an array of games and we want to create a new object from it. So I'm going to say that my initial value in this case is not 0 because we are manipulating arrays and data. So I'm going to specify it as an empty object. Okay, and then I'm going to write inside, each time reduce iterates over the games array, I will transform this empty object in something else. And in the end, we will have a complete object with all my computer games. Okay, so instead of reducer, I'm going to inline the reducer here. I hope I'm not committing any mistake right now. So okay, accumulator and current value. That's all we need, folks. And now this is where the magic will happen. What do we need to do? So each time reduce iterates over one of the game objects, we need to know which is the year of the game so that we can kind of fit it into our new object. So I'm going to start with destructuring year from the current value. So I don't know if you already know about destructuring, but basically what I'm writing here is create a variable called year, using the year inside the current value. Okay, so from this point on I can just call year and it will refer to the year of each one of the current objects that are being iterated. And now what do I need to do? I'm going to return something. I'm going to return an object. See that when I return an object, basically I'm creating a new object. So what do we want to do? We want to spread the accumulator, because accumulator is going to be an object that is being incremented each time we iterate over a new game. So I'm creating a new object with the brackets and I'm spreading the old object here. And now what I'm going to do is I'm going to use the year variable that we've destructured on line 17, and I'm going to say that I want to spread the value that already existed in the year key so I want to spread this value, and I want to put current value here, so that we add our current game to the year. So let's see if this works. Let's see if this works. It doesn't work. It's failing because sometimes, or in the beginning, ACC might not be iterable. So what I need to do here is say that if ACC.year doesn't exist, use an empty array because it's iterable. Okay. And of course I didn't console log it, so I'm going to console log the games object, and now, yes, now we see that our computer games are sorted by year, and now it's much more useful to know which games I have that were made in 1984. I just need to say that 84 games, or games from 84 are games objects 1984, and let's expect this works. Yes, it works. Okay, you see, this is the kind of transformation that you need to do. This example was a little bit more complex than expected. You need to know a little bit about the structuring, about the spread rest operator, but I thought it was useful to show you something more used in your daily life as a developer. So one important thing to notice is that reduce does not mutate the original array. Instead, it creates a new array, object or value from it, preserving the original one. And that's all for today, folks. If you have any questions, don't be shy. There are no dumb questions. Just reach out and I'll be happy to answer you soon. Hope you have enjoyed this small explanation about reduce higher order function, and see you around. Bye bye.